This is a long presentation, so here we go. This is who I am, and you've already heard a little bit about me, but in 1996, I moved to a farm in Wise County, Texas, right in the middle of where George Mitchell was experimenting to learn how to frack oil and gas from shale. The first well that was successful was drilled in 1997 near my farm. In 2005, that's when the fracking boom began. That's because that's when Dick Cheney had hydraulic fracturing exempt from oversight by the Clean Water Act. By then, and my air had already turned brown and my well water turned black before then. So it was in the early 2000s when that happened. But I eventually learned about optical gas imaging technology that makes the invisible pollution visible, and I thought, yeah, that's the key. That is going to be a game changer. I started using a borrowed camera from Calvin Tillman. Some of y'all know Calvin Tillman. I started using his camera in 2013, and in 2014, I was certified as an optical gas imaging thermographer. So I have spent 28 years sitting on the side of the road, watching oil and gas and connecting dots they don't want me to connect. And I've spent over 11 years with an optical gas imaging camera in my hand. And this is the instrument. It's actually an instrument, and when I put this lens on it, it's about this big, really heavy. It's an optical gas imaging instrument. It has a filter that is specifically tuned to the very narrow range right here. Do you see this little pointer? Right here in the mid-wave infrared. That's where hydrocarbons absorb infrared. This rainbow color is where humans see. So we cannot see hydrocarbons with our bare eye. But as you can see with this chevron flare that they forgot to light, as the hydrocarbon gases emit from this flare, they absorb infrared, and then the camera visualizes them for us. It has an onboard camera. That's why they call it a camera. It's not really a camera. It's an instrument. It's a scientific instrument with an onboard camera. It does detect heat, but unlike what the industry says, that it just detects heat, that is not true. It's an optical gas imaging instrument. And so this is what we're going to talk about today. What's in between this green line, this is a cartoon. If this were reality, it would have a bunch of oil spilled all over it. It'd have smoke coming out everywhere, flames, a whole lot more stuff all in there. This is a cartoon. And this is what it takes to get the natural gas that is produced in Arlington to homes and to power plants. This right down here, this is not what we're talking about. This is oil. The crude oil goes to a refinery. That becomes gasoline, which we call gas. That's what you put in your car. It's not really gas. It's gasoline. It's a liquid. So this is about methane gas. The industry calls it natural gas, but it's really methane gas. LNG is liquefied natural gas, and that's really methane. And so it starts right here. These are supposed to be wellheads, and that's where it starts. That's where drilling, fracking, completion, and flowback and production happens, right there in that little blue line. That's what Arlington experiences. You do have a little bit of processing and a little bit of compression, but mostly it's what's in this blue line. So what happens at the well site, the wellhead, is everything comes up together. the liquids, the gas, the oil, everything comes up together. And methane brings with it other gases that we call hitchhikers, that are like benzene and hydrogen sulfide, which is deadly. Then also what happens to the gas, we have compression, we have processing, compression, transportation, liquefaction, regasification, and then it goes to power plants or through into your home. So I have to have some notes or I'll talk a long time about one thing and forget other things. So this is drilling, and this is an example from Arlington. This is at the High Point site in Arlington. During drilling, all this movement you see, that's gas moving. And they're not allowed to use diesel rigs anymore, although they did sneak in one time and used one anyway. But so the pollution is not coming from a diesel rig. They could have other equipment that it's coming from, but I'm going to show you where it's coming from in just a minute. People complain about chemical odors. This is from the 25th. That first one was one from the 10th of May. And you can see the gas moving right here. People complain about odors, noise, lights, vibrations that shake their home, those kinds of things during drilling. It takes a couple minutes for me to get to the next slide sometimes. Okay. This is, if you could see inside the walls they put up, you'd see a lot of stuff going on that you wouldn't like. But this piece of equipment right here is called a gas buster. And so they mix up mud, and some of y'all, y'all already know all of this stuff. I know Gary Hogan knows all of this. They mix up mud, they mix chemicals in the mud, they mix lubricants in the mud. The mud goes down a pipe through the drill bit. It comes out the end of the drill bit and back up, and it flushes up back to the top of the hole where they're drilling. It carries, the drilling mud is to lubricate and keep the drill bit cool, but it also is cleaning out the hole. It's cleaning out the drill bit cuttings, the pieces of shale, and it's got a whole lot of gas in it. So if they want to reuse this mud because it's expensive. They've put all their chemicals and stuff in it, so they want to reuse it. So they send it through a process. They send it through a shale shaker and get the chunks out, and all of this back here, or part of that, is where they take this mud. The mud is hot. It's off-gassing the gases that are in it, and that's part of where the odor's coming from, your exposures. But then they can't put mud with gas in it back down whole, or it will cause a blowout. And Arlington experienced a blowout here quite a while back, and it was pretty horrific. They lose control of the well, and everything downhole just starts shooting up. So here's what they do. They put the mud in right here, and it falls down to the bottom, and the gas goes up to the top. And this is where when the gas is out of the mud, it'll go on back and be reused. But see this right here? Vent line. What do you think that does? It vents all that gas into your air. Now, there's another way to handle this, and y'all aren't going to like it. But in my opinion, it would be better than just venting all of this. And they can, instead of venting it, they can hook it up to a flare or to a combustor. And I know y'all hate flares. People hate flares, but flares serve a purpose. They do, it's better than venting. But, people went nuts over flares when they first started in the Barnett Shale. And so a lot of environmental groups thought, we'll ban flares. Probably not the best idea. If you are going to have oil and gas in your city, in your backyard, you will have vented hydrocarbons or flares. You can't say I'll have neither if you're going to have oil and gas. You have to have one. And in my opinion, it is better to have a flare. Okay, so then the next thing they do is fracking, and this again is a cartoon. And in the beginning, we didn't have this thing over here that shows this. We just had this. And I used to wonder, that's a steel pipe, and they're supposed to put cement around it. Does the gas go in the other end? How does it get in the pipe? I could not figure it out because we didn't have this back at the beginning. But they bring in more than 1,000 chemicals, and y'all know a lot of this already. All of the chemicals, not all of the chemicals, but a lot of them are toxic, poison. They say on the containers that the chemicals are in, they have little labels on them that say toxic, poison, and they're all stacked up on the site, and they mix all that together, and they put it downhole with sand and all this other stuff. I'm not going to go into a lot of detail here, but downhole, those chemicals mix with all the hydrocarbons, the heavy metals, the radioactive material, all of that mixes together, and magic happens downhole, because when it comes back uphole, the law says it's not hazardous. It's not hazardous waste when it comes back. It's hazardous when it goes downhole, but it's not hazardous when it comes back uphole. And we know that they don't use all 1,000 known chemicals in each frac. They pick and choose what they want to use. But of the 1,000 chemicals we know of, 100 are endocrine disruptors, and about 50 are potentially carcinogenic. And that's not even counting what's in the formation that they bring up with it. In 1988 is when oil and gas waste was designated as non-hazardous by the Resource Conservation and Recovery Act. And we've been trying ever since then to get oil and gas designated as hazardous. But let me tell you, if the oil and gas had to handle their waste as hazardous waste, oil and gas would be over. They wouldn't be able to afford it. So their friends in our Congress give them a handout. Okay, so then I figured out, I had to figure out how they made these holes in the pipes. Do y'all know how they make the holes in the pipes? I know Gary knows. So I was driving around in South Texas, and I saw this truck, that white truck right there, and it was an oil and gas truck. And it had this trailer, and there's a sign right here on the trailer that says, danger explosives. And this right here looks like drill pipe. And so I'm going, they've got explosives in the drill pipes? And so I followed that truck, and it turned into a site where they were fracking. And that's when I learned about perf guns. So perf guns blow holes in the pipe. It's armor-piercing explosives that I'm sure they do not carry it around on trucks like this. I'm sure that they had so many accidents with it. I'm sure they have a better method now. But in Arlington, next to your backyards, they are setting off charges with armor-piercing explosives. And so what they do is they have a rig that holds these pieces of pipe like this, and I have seen videos where they're swinging, and they put these loaded charges down hole, and then they blow holes in the pipe, and it's a lot. You can look it up on YouTube. It's a very long process. They have to put a plug in here, and they blow a hole, and then they frack that section, and then they put a plug in, and it's very complicated. But the point is, they've had a lot of accidents, and one man that I read about had both legs blown off, and when the charge went off before they got the pipe down hole, and he bled out on site. And they've had numerous accidents and people die. The charges are set off electronically, so you're not allowed to bring a cell phone on site when they're doing this process. But what about your teenage daughter who's walking by this site talking to her boyfriend? You know, it's just mind-blowing to me. And I'm not an expert on perf guns, but it's mind-blowing the amount of danger that they put people in. And then the next stage is flowback. And this is when they did flowback on Memorial Day in Arlington. I went out and filmed this. They tested flowback, and it is one of the most dangerous stages. Exposure to these emissions is very, very dangerous. Benzene is naturally occurring in crude oil and gas. Back in 1897, I'm going to keep playing this so y'all can watch it. In 1897 is when they first knew that benzene caused bone cancer and abnormal aplastic anemia, which they thought would lead to leukemia, which we found out later that it did. 1897, they have known that long. Then in 1948, the American Petroleum Institute commissioned Harvard Medical School to do a study on benzene, and they found that there is no safe level of exposure to benzene. That was commissioned by the American Petroleum Institute. So since 1948, they have known about this, and they still fight even the most sensible regulations, the most sensible setbacks. They do not want to even set back 300 feet from a preschool. And their workers go on site and get these same exposures. In 2011, when fracking first started, and I know Gary's going to remember this, they did a $1 million air study. It was very thorough, but not transparent. And they studied, took samples on all these sites. And when they got through, they released the results with this dizzying spin. Air is safe in the Barnett Shale, no need to worry, blah, blah, blah. It was over 1,000 pages. So in order, they released it, and the media wrote all of this, glowing reports, and then we have to dig in to those 1,000 pages and try to figure out what really happened. They found benzene 94% of the time in that study, and so much other stuff. You know how the Barnett Shale doesn't have any hydrogen sulfide? They told us that. They found a lot of hydrogen sulfide in the Barnett Shale. But they found rates of benzene and other volatile organic compounds are the highest during flowback. And I know that Ranjana keeps y'all all updated on the latest studies and everything. I know she sent out the study recently from Colorado where they said it's not just the proximity to well sites that's the danger, it's how many wells your children are being exposed to is what increases their risk of cancer. So, yeah. So here's another thing that I'm going to tell you about flowback that you're not going to like, but it would be better. So the flowback tanks are big, like what tractor trailers pull around, and they have vents on the top, and the flowback comes out the vent. Horrible, horrible stuff. They don't have to do it that way. They can combust the flowback. They have to vent it because it is so volatile that it'll explode the tanks. But instead of venting it, they could combust it. That's not perfect. It still puts out a lot of pollution, but it's not as bad. So I'm just saying that's an alternative. So now we're going to get to the production stage. And I didn't have a good video in Arlington of this. I have taken videos of Arlington sites where they're doing pressure release. This is in Fort Worth, and I just took this video last year. I was with a reporter who never released his report and asked me to hold the videos. I want you to look at this right here. This is a tank hatch. Now remember that because we're going to talk about that in a minute. But what's happening here is the tanks are building up pressure that has to be released, and they release them through these pressure relief valves on the tanks. They don't have to do it that way. They could collect all of the vapors from the tanks and put it in the pipeline. Arlington doesn't make them do that. So I'm going to give you a little physics lesson here. This is what happens. The tanks are not meant to hold gas. Tanks are meant to hold liquids. And when they say the Barnett Shale only has dry gas, it's a lot of liquids because there's a lot of tanks on all of these sites. But the gas is mixed in with everything. It gets in the tanks, then it separates, rises to the top, creates pressure, and it will blow the tanks up if they don't release it. So that's a law of physics. It's required. And that's a huge problem that the industry doesn't follow a lot of laws, in my experience, but they follow that one. And here's, when I asked you to remember the tank hatch, this happens in Arlington too. They send workers out to sites and they open that tank hatch and all that gas is built up in the tank and it blasts out like this. And when Mother's Heart daycare director, Wanda, I think, she was outside in the play yard and they caught on surveillance camera a man doing this manual gauging and thieving right behind that playground. She and one of her employees were overcome and made very sick, and they had to, leave. That's what's happening here. 3 workers a year die on site from doing this. Let's say just last year, more than 3 died, and one of them made it to his truck. Most of them just die right there or fall off of the catwalk. One guy made it to his truck, and he was found dead in his truck. We have no clue how many workers go home and weeks or months or years later get sick and die. But this should not be happening in Arlington. Even the American Petroleum Institute says there are alternative methods. This should not happen in Arlington. And I'm giving y'all some information here about things that you could advocate for to try to make it better. Still isn't going to be great, but it could be better. So to deal with their physics problem, the industry has come up with these technology solutions, and you probably hear about their technology solutions all the time. And they really talk about this a lot, and here's where the vapor recovery unit is failing in a really big way, and we catch this one failing pretty often. In fact, 75 to 80% of the time is what Tim Doty has estimated that he catches vapor recovery units failing. We're not saying that vapor recovery can't work. We're saying we find it not working a lot. But it needs, all of these technologies need constant maintenance and repair. All of the parts have to be cleaned. Well, guess what? That costs the industry money. And they're laying off workers, and it's a box. There's a form with a box that they check. Vapor recovery, auto relight on the flare. They just check it, they put it aside, and they don't look at it again. And it makes us think, oh, good. I used to think vapor recovery units that was the way. We were all going to be safe with vapor recovery units until I got an OGI camera. So here's another thing that industry claims. They talk about leaks, and I hope that y'all will all never say the word leak again when you're talking about oil and gas. Don't say leak. You are greenwashing for the industry if you say leak, because right here, this is the Greenhouse Gas Reporting Program. That's where the industry does their own reporting for the emissions that they're releasing. Right down here, fugitive. That's the same as a leak. It's an accidental, unintentional release. 6%. 6% is what they admit are leaks. The rest of it is standard operating procedures, some accidents, but it's standard operating procedures that are required. What you see in this video here, that is not a leak. That is a pressure release. This is a leak. See the difference? They tried to fix it with duct tape, and that's working about as well as any of their other fixes that I've seen. But that is an unintentional leak. Unintentional methane leaks are a sideshow. Intentional pressure releases are the feature. And when we're talking about the greenhouse gas reporting program, and I know everybody was really upset when Trump did away with that, not me. It's all a bunch of lies. It's a bunch of lies. This is how much lying it is right here. This is measured emissions in the Permian. This is what the industry admitted to. That's how much lying they're doing. If you take the greenhouse gas reporting, you have to multiply it by 5 or 6 to get to any kind of realistic number. They've been doing that since 2011. Now, what do you think would happen if you underestimated your income tax for 15 years? Would that be called fraud? Yeah, just saying. And I know y'all don't have flares, but flares are part of the production process in most places, and they're often unlit. I find them unlit all the time. I can tell you some crazy stories about unlit flares. They have technology. Don't worry about unlit flares. We have technology that solves that. We have auto relight, and we have sensors that tell us, yeah, I still find flares unlit all the time with auto relight technology and sensors. I found a BP flare unlit in South Texas, and it was about 2 weeks before I finished my trip and I could make the complaint and notify TCEQ. surprisingly, they got out there with a couple of weeks. So by then it'd been a month since I found the flare unlit. And in the investigation that went on, it was about 6 weeks, and then BP said, oh, we had a camera trained on that flare to let us know when it was lit or not lit, and we had auto relight, and we had these sensors to let us know, but they stopped working a while back, and so they weren't even looking at it. So unlit flares are another problem. But oil production has increased 5%. That's just oil. Since 2019, the workforce has been cut 20%. And this is processing. This video is going to be a little bit hard to watch. Trust me, when I was taking it, it was a little hard to watch. This is a blowdown at a processing plant. Processing plants are bad enough just when normal operations, but this was a blowdown. They were just dumping gas into the air. I don't know why they did that. They're supposed to report blowdowns to the state, but this was not reported. I don't know how many blowdowns I've recorded, dozens. Never once has one been reported. But they could have been having an emergency. They could, they get a lot of get out of jail free cards for stuff like this. They just have to make up something that was an emergency and they had to dump the gas. And they're forgiven, but they still don't report it. But it could be many, many reasons. Sometimes they have blowdowns just because they don't like the kind of gas it is. It doesn't meet their specs. Most of, high levels of methane going out into our atmosphere, VOCs, because they don't like the specs. That's enough of that. So the next stage will be compressors. And they have compressors, all different kinds of compressors. They have some on site here in Arlington. They have compressor stations. This is in Arlington. They call this a compressor facility. I want to stop it right here. But it also has processing, which is separating out the different gases, getting the liquids out of the gas. This is the site right here, inside this red. This is Campo Verde, where we used to go after football games to eat Mexican food. This is a medical clinic. This is where children take karate. This is Arlington ISD Ag Center. And believe me when I tell you that the emissions from this site carry over to there. They are horrific. And so this is a compilation of videos that I have taken at this site over the years, and some of them were taken when I was with Earthworks, and the last video was just taken last year when I was there with Ranjana again. So this is a combustor, which is what I keep telling y'all should have them combust, but it's not working right. They can work and be more efficient than that. It's not perfect. This is a stack. I think that is a heater treater that is heating up the gas and liquids to do the separation. But you can see it's headed right toward Campo Verde. I believe that the compressors are in this barn-looking thing, and they are venting the gas from where those compressors are. But I've never seen the compressors, but it says it's a compressor facility, so they must be there. And look right here. This is a little pipe that's venting. We're going to see that better in just a minute. This is a video I took last year. And I'm going to stop it right here. wait, stop. Stop right there. Okay. So right here on the side, this is a histogram. Now, you know how the industry, I don't know if y'all know this, but they go, oh, that's just heat. She doesn't know what she's talking about. That's just heat. This tells you what's heat and what's not heat. So the bright white down here is the hottest part of this equipment. And the red is still very hot. Yellow is hot. Green is starting to cool off. But the blues and the lavender or hot pink or whatever color that is, that's pretty much ambient temperature. So that's not just heat. That is volatile organic compounds, particulate matter. It's got formaldehyde in it, but the camera doesn't see formaldehyde. But, you know, that's a lot. That's a lot coming out in this neighborhood area. And right here, you're going to see that little pipe again, and it really gets going here. Look at this. That's just blasting out hydrocarbons. That's unheated, just blasting out hydrocarbons there. That's a really pretty horrible sight. Okay, here's another compressor station. This is in the Permian. This is an Energy Transfer Partners site, and they're having a blowdown. So they're just blowing all the gas out into the atmosphere. We were here for well over an hour. I was with a Japanese media crew. The blowdown I showed you at the processing plant, we were there for an hour. So, I mean, they didn't report this. It was never reported. I did figure out why they were having a blowdown, because not far from this site, I found another compressor station just about a mile away that was also having a blowdown, and both of them send gas to the Red Bluff gas plant, processing plant. And the processing plant, no lights were on, the whole thing was shut down. So I don't know how long it was shut down. I tried to find out. I don't know. It was over a week. The well sites that are producing the gas, they don't get a memo that says, hold off. They just keep producing. It keeps going in the pipeline, and then it just keeps going into the atmosphere because they don't have any place to put it. This is a compressor station that's under normal operations. The white is the equipment that's really, really hot, and there's some exhaust coming out from it. Right here, that and this, and this. Those are pressure releases. Now, I thought a compressor was supposed to put the gas in the pipeline, okay? That's the purpose of it. It compresses it, and it puts it in the pipeline. So when I first saw this, I'm like, what is happening? And oil and gas workers told me, well, you can't put gas over pressure in the pipeline. We have to just vent it. If it's over pressure, we just have to vent it. So if they're producing too much gas is coming into the compressor station, they just have to, it's a pressure release. They just have to let it go. And now we're to the transportation stage where they do put the gas in the pipeline. But guess what? This is a blowdown. So a lot of what you see when they say, we got this plume from space, those are pipeline blowdowns. That's when everything is an emergency, and they have other ways that they can handle this, but if they have an emergency, they have to blow the gas out. If they want to clean the pipeline, if something downstream is not working, the pipelines get over pressure and they have to blow it out. Right now, Pakistan has so much solar, they've solar all over Pakistan, that their whole grid, their whole gas pipeline grid it's dangerously overpressured. So that's going to blow up unless they get somebody to take it. They can send it to an LNG terminal, or they'll just dump it in the air. Y'all are sighing. Are you getting depressed? Okay, and now we're to liquefaction. This is where they liquefy it. Let me get to my notes. Yeah. This is where they liquefy it. They cool it down to minus 260 degrees Fahrenheit, and at that point, it's 1/600th of the volume, and then they put it in the tanks on the tanker ships. So this is a site in Louisiana, and there's a new study by Robert Howarth, and y'all might remember in 2011 he released a study that said natural gas is worse for climate than coal. People hated him. Lots of environmental organizations, Sierra Club, lots of them. They attacked him. Guess what? So many studies have happened since then, they found out he's right. Well, he just released a study on LNG, and he said it's the worst fossil fuel you can use. It's 30% 30% greater than for coal, the greenhouse gas footprint for LNG. So that's what an LNG liquefaction site looks like. Now this is so new, I had to write it on my notes. I went back to that site in February and got a video of the emissions from a ship. So there was a reporter with me, and they did an analysis, and they found that 1 year of greenhouse gas emissions from tankers carrying LNG from the U.S. cancels out annual emission reductions achieved through all the electric vehicles currently on U.S. roads. So they want us to believe LNG is clean, and that's the way forward. And in February, I got to go to Japan and film a regasification plant. Now that's where they take the liquefied gas off of the ships and they regasify it. And to do that, one way that they do that, the way they did this at this terminal, they heat up seawater and they bathe the tanks, or they use that to heat up the methane. Now, did y'all pay attention with the physics about pressure, volume, and temperature? It has to all remain constant. So what a surprise that at a regasification plant, there's just gas going everywhere. So we went out on this beautiful sailboat. It was very fun, very cold, and I got to film this regasification plant. As far as I know, I'm the only person who has this. And there are the methane emissions. Now, I'm on a boat, so, we're moving, and I'm doing the best I can, but, you can see the clouds of methane over that regasification plant. It's going to switch to, I want it to, okay, there, see, I have to point out steam, because if I don't point out that I know I'm smart enough to know steam from invisible emissions, the industry will say, she doesn't know the difference between steam and emissions. And so you can see here in the rainbow palette, you can kind of see where the cloud of the methane is, and there's more steam, like, anybody. It's totally different characteristics than hydrocarbons, but I should have cut this video down. Okay, and here's a lot of emissions over the tanks that's holding the LNG it's not liquefied anymore, I guess. And then here is combustor, and look at that cloud. It looks like a bear's head, but the emissions, see, are going way up over that cloud, that bear's head cloud. And then now we're to the power plant. We're almost there. This is in El Paso. I took this with my iPhone looking at the LED screen on the camera. That's clean burning natural gas. And now you might think that in Japan, they engineer everything in Japan. You can get a straw this big, and I thought, what am I going to do with that? It telescopes out. They engineer everything. But let's see how they're doing on their power plants. Look at that, pumping out. And you can see that's not heat. And then here's a different view in auto mode. And you can see how far this pollution is going. I'm going to speed it up here and then here's a little bit more of the plant. So even Japan, with the best engineers in the world, cannot make natural gas clean. So I stole this from Al Gore. This is our troposphere. It's 3.7 to 10 miles. That's the lowest part of the atmosphere. I can walk 3.7 miles in less than an hour. I could walk from the Earth up to the troposphere. That contains all the oxygen and other gases that we need for life. That's where weather occurs. It's where water vapor, clouds, precipitation, our water cycle, that happens there. That's where all the greenhouse gases are, in that little space right there. So we're using the troposphere for an open sewer. And I've showed you just a tiny sliver, not even a sliver, the head of a pin of what I've seen. There are millions of oil and gas sites all over the place. There's oil and gas, there's methane combustion everywhere. Our cars combust the gasoline. We are dumping so much. That's our oxygen. That's our life right there. And that's where all the greenhouse gases are going. And so that's what's happening to our planet. And I just can't wait for the day when the day is here. We no longer need to combust. We don't need to burn anything for energy. We have everything we need. We have battery backup that makes all that nonsense about when the sun don't shine and the wind don't blow. And California is doing it. California is running their electricity on renewable energy days and days and days at a time. So, I guess we're going to have, there's a summary there, but y'all can read it. But I want to show y'all my favorite joke right now. This guy, honey, come look, I found some information all the world's top scientists and doctors missed. So what I told you here is facts. The industry has tried twice to put slap suits on me. Well, they have. They've tried to sue me with slap suits. They didn't win. I won, because facts, even when delivered with some sass and some ridicule, facts are facts. It's not against the law to be sarcastic. I don't care if, they don't like it, but it's not against the law. So yeah, what I told you here is facts, and so I'm happy to take questions, and here's how you can find me. Thank you.